Let's take a look at this example. I would start solving this problem from finding angle theta. So you remember that the formula for power factor is power factor equals cosine of angle theta, or this is equal resistance over total impedance. Now I have resistance and I have total impedance. So I can write that this is cosine of angle theta equals resistance over total impedance. This is going to be equal to angle theta equals inverse cosine R over Z. Okay, of course this is Z total. You can add T to Z in order to remember that this is Z total. So next, I'm supposed to simply plug in the values into my formula. So I have theta equals inverse cosine, and I have resistance equal 300 ohms, and total impedance is equal 500 ohms. Use the calculator and calculate the angle theta. So you're supposed to get the value of negative 53.13 degrees. Someone is going to say, why did you get negative? Because from the calculator you are going to get the positive value. But you're supposed to realize that we are dealing with the RC circuit. In the RC circuit, total impedance is going to have always negative angle. So that's why you are going to have negative angle with your theta. You cannot forget about it. So anytime you have resistor and capacitor, your total impedance is going to have always negative angle. So I can write right now that my Z total is equal 500 ohms and angle of negative 53.13 degrees. It's my Z total. But the problem is not asking me for Z total. I have to find X of C. How I can do that? You're supposed to write the formula for Z total. Okay, so if Z total is equal resistance plus X of C. I have given resistance, I found Z total, so I can use just simple algebra to find X of C. So X of C is equal Z total minus resistance. Okay, I simply move R to the left side and I'm going to have X of C equals Z total minus R, where Z total we found is equal 500 ohms and angle of negative 53.13 degrees minus resistance, which is equal 300 ohms. Use the calculator and you're supposed to get the value 400 ohms and angle of negative 90 degrees. So this is the value of the capacitive reactance. Next, we're supposed to find the total current. In order to find total current, I'm going to use Ohm's law. I total is equal voltage source over Z total, where voltage source is given has value of 400 volts, and if angle is not given, we assume that this is angle 0 degrees, over Z total, which is equal 500 ohms and angle of negative 53.13 degrees. This is equal. Use the calculator and you will get the value 800 milliamps and angle of 53.13 degrees. And this is the current, total current in my circuit. Remember that this is a series circuit, and in series circuit the current is the same, okay, at every single component. So I can say that this current is also equal to the current which goes through the resistor, and is also equal to the current which goes through the capacitor. In order to find voltage across the resistor, I'm going to use Ohm's law and simply remember that voltage across the resistor is equal current which goes through the resistor times the resistance, where current which goes through the resistor is equal 800 milliamps and angle of 53.13 degrees times the resistance, which is equal 300 ohms. Use the calculator. You're supposed to get the value 240 volts and angle of 53.13 degrees. Okay, I always say use the calculator because I want you to practice using the calculator with the complex numbers, because we have to get prepared for more complex exercises. So that's why your calculator skills are very important to me. So next, we're supposed to find the voltage across the capacitor. VC, which is equal current IC times X of C, which is equal 800 milliamps and angle of 53.13 degrees. And times X of C, which is equal, we found it, is equal 400 ohms and angle of negative 90 degrees. Okay, so this is equal 320 volts and angle of negative 36.87 degrees. So this is the voltage across the capacitor. In order to verify that our answers are correct, you're supposed to use KVL, Kirchhoff voltage law, which says that the voltage source is equal the sum of the voltage drops in the circuit, the series circuit. So we have voltage across the resistor plus voltage across the capacitor supposed to give me value close or equal to voltage source, where VR is equal 240 volts and angle of 53.13 degrees plus 320 volts and angle of negative 36.87 degrees. So if you are going to add these two values together, you're supposed to obtain 400 volts and angle of negative 0.0001 degrees. So as you can see, we get value 400 and we can say angle of 0 degrees, and this is the same value which we had at the beginning. So it means that everything, whatever we did up to this point, is correct. Now we're supposed to find capacitance. In order to find capacitance, I'm going to use the formula for the capacitive reactance, which says X of C is equal to 1 over 2 pi Fc. I have to solve this formula for C. In order to find C, I have to multiply both sides of my formula by 2 pi Fc. 2 pi fc. Okay, so 2 pi fc and 2 pi fc will cancel out, and I'm going to have 2 pi fc x of c is equal 1. In order to find c, I have to divide both sides of my formula by 2 pi f x of c. 2 pi f x of c. So x of c and x of c will cancel out, 2 pi f and 2 pi f will cancel out. So fc is equal 1 over 2 pi f x of c. Next, we're supposed to plug in the values, and we will have 1 over 2 pi f frequency is equal 160 Hertz times x of c, which is equal 400 ohms. We've found it. Please notice that I do not include the angle if I'm looking for C. Plugging these values into the calculator, you're supposed to get 2.48 microfarads. Okay, so this is the capacitance in my circuit. Next, I'm supposed to find the power factor. We said that the power factor is equal to the cosine of angle theta, or R over Z total, where R is equal 300 ohms and Z total is equal 500 ohms. Okay, if you are going to divide 300 by 500, you will get 0.6. Now, because we talk about the series RC circuit, you're supposed to realize that the total current is going to lead the voltage. That's why anytime total current leads the voltage source, you're supposed to write next to the value of power factor leads. Okay, so this is the value of my power factor. We found the capacitance, we found all currents and voltages, so we can say that the problem is solved.